Hello and welcome to another video tutorial about FreeCAD. In this video tutorial we are going to model this wiffle ball shown here on the screen, and we will use the part workbench this time. As you may remember from the last lesson with the Turnus cube, we used the part design workbench, whose basic idea is that you draw sketches and extrude or revolve them into 3D shapes. The part workbench has a different workflow. As you can see here from its symbols, it will allow you either to insert part primitives and do Boolean operations with them. You can either fuse them, you can cut shapes, or you can make an intersection of the shapes. But also the part workbench has methods of drawing sketches and extruding and revolving them, or doing something like loft or sweep. These icons cited here are for measurement purposes. So let's begin with our lesson. So now I'm going to close this document here, and I'm going to create a new document. The first thing I will do is insert a cube. As you can see here, a cube was inserted with standard dimensions and a standard position. I just changed here to axometric view, and now I say fit all to be sure that I have everything on screen. So if I highlight here in the tree view the cube and switch to the data tab, it tells me that the standard cube has 10 millimeters length, 10 millimeters width, and 10 millimeters height. So we are going to change these values by clicking one time inside this box, and we will change the length to be of 90 millimeters, and we will also change the other two values to be also 90 millimeters. Let's repeat the fit all command to zoom out, and if I change now to wireframe mode, and if I say view toggle axis cross, you will see that the cube was inserted at this position. Here is the origin. Since it is a good idea when modeling in 3D space to use symmetry wherever possible, I would say that it is a very good idea to move the object that the origin is in the middle of the cube. We can accomplish this by highlighting the cube in the tree view and changing its placement here. You click in this box on the right side, and then you see three dots appear. You click once more on the three dots, and now you can change the placement values of the cube. At the moment it is centered at 0, 0, 0, and it has no rotation. So the first thing I'll do, because it's my personal preference, I'll apply incremental changes to an object placement. I rarely do all changes at once, because that allows me to control a little bit if everything is going the right way. So I tick this box and say to move the object to the correct location, I will first correct the value of the x-axis. Since we applied 90 millimeters to this distance here, I will correct the x value by highlighting the 0 and then entering with the keyboard minus 45 millimeters. As you can see here, the object did move, in X direction, to be correct in negative X direction, by 45 millimeters. We will repeat these operations with the Y and the Z axis every time minus 45 millimeters. As you can see, if I rotate the object a little bit, the origin is now where I want it to be, exactly in the middle of the cube. I click on Apply to make sure that the values are entered, and I say OK. And as you can see here, these placement values did now change. So I go back to axisymmetric view, I say Fit All, and I say View Toggle Axis Cross to get rid of the axis cross at the moment. So the next step would be to insert another cube. So I click on the Insert Cube icon, and as you can see here, this cube is also inserted at the origin with the standard values of 10 millimeter each dimension. As I highlight it here in the tree view and make sure I have switched to the Data tab here, you see the values appear here. Okay, this time we will change the cube to have 80 millimeter in every direction. And now we have to change the placement as well. So I did click one time here in the placement row, and then I click on these three small dots here, and now I make sure to apply incremental changes, and I will move the object in negative X direction about 40 millimeters. The same with the Y and the Z direction. I click on Apply. You see, if I clicked on Apply, these values are resetted because I clicked Apply Incremental Changes. And the dialog would be ready to accept further instructions. So now I click on OK, and I've inserted the second cube successfully. So now we will do a Boolean operation. We will highlight here in the tree view the cube. When we do a multi-select by pressing Ctrl, keep Ctrl pressed, and highlight cube 001. Now we will perform a Boolean cut by clicking on the second icon here in this arrangement. Now, as you can see here, I did a cut between I did cut away the volume of cube 001 from the volume of the cube. And now they are toggled invisible, these two cubes, so that the new shape, which is actual and present, is the cut shape. So the next step would be to insert a cylinder. As you can see here, the cylinder is inserted with standard position and standard dimension values. So I click on the cylinder and look at the Data tab. The radius I will change to be 27,5 millimeters, and the eighth I will change to be 90 millimeters. And now I must correct the placement. So I click here, and now I click on the three dots, and I will correct placement in negative Z direction by 45 millimeters. I click on apply. Okay, that's it. Now I will do once more a Boolean operation, a Boolean cut. So I highlight the cut shape. I press Ctrl and keep Ctrl pressed. I highlight the cylinder and click on cut. Let's change the view to as is, and you can see what we just did. We made a hollow box with two cylindrical openings. Here I choose the cylinder to be of the same height as the box, which is not every time a very good idea when performing Boolean operations. It could be successful, but there are some times, occasions when you have coplanar faces that the Boolean operation will fail. So it is often a better idea to have overlapping shapes when performing Boolean operations. Okay, now we will change back to wireframe mode to have a better visual representation of what is going on. We will minimize this view here, and we will insert a second cylinder. With cylinder, I will also change the dimensional values. The radius, we will have 27,5 millimeters, and the 8 should be 90 millimeters. I click an empty space. So you see we have here the second cylinder inserted. I will highlight the cylinder again because I need the placement to be changed as well. So I will click here into placement row, and then I will click on these three dots, and I will make sure that incremental changes are applied. So the first thing I will do is I will rotate the cylinder around the x-axis. So I switch here to the x-axis, and let's try an angle of 90 degrees. This looks like the perfect orientation, but the position is not okay. As you can see here, I have to correct the position in the y-axis direction. Okay, I click apply to accept the changes I just did, and then I correct the value of the y-axis by minus 45. No, sorry, my fault. We are not going in negative direction, we are going in positive direction by 45 millimeters. This looks good. I click on apply, say OK, and then I will perform another Boolean cut with these shapes. So I mark here cut 001. I press Ctrl, keep Ctrl pressed, and do highlight these the cylinder I just inserted, and then I will perform a cut, and that's it. Okay, now we will insert another cylinder. We will highlight this cylinder here in the tree view. We will change the dimensions also to 27,5 millimeters. and V8 to be 90 millimeters. And when we need the placement to be changed, I will apply an incremental change. And now I will not rotate about the X axis, I will rotate about the Y axis. Okay, so we change here to Y. We apply 90-degree change. This looks very good. We say apply. And then we have to correct the value of the X axis, this time in negative direction, minus 45. Because we applied here 90 millimeters, and then we did move the main cylinder to be placed so that the origin is in the middle of the box, so it makes 45 millimeters as correction value. We click on apply and say OK, and we apply also a Boolean cad to these two shapes. Remember to highlight the first shape, the base shape you can call it, and then doing a multi-selection by highlighting the shape which has to be cut off. And then you perform a cut. As we change the view mode, you see what we have just done here. So we change the axometric view, save it all. And now we have done our first operations in the part workbench. Of course, I did here several cut steps, one after each other, to show you how the logic of these operations works. In real life, you could speed up the operation by inserting a second cube and the three cylinders by correcting their dimensions and placements. And then you could do a union of several shapes, in this case the secondly inserted cube and the three cylinders, and then you could do a Boolean cad of the first cube and the just multi-fused shapes. That would be a little bit more efficient in this way. Now for the last step of our operations, we want to cut off the corners of this box. Of course, we could do this by inserting cubes and making Boolean cuts with the cubes, but I like to show you another way. For this other way, we will need the part design workbench, and since you want to cut away material, you would normally use the pocket operation. In this case, this is not possible because the pocket operation needs a sketch mapped to the face of an existing object. In this case, we would need a shape in the middle of a material, you could say, and then you would cut away the material. And this is not possible with a pocket operation in FreeCAD at the moment. So we have to take another approach. We have to do a solid object, and then we could cut the solid object from the basic box. So I will begin with inserting a sketch. In this time we will use the XZ plane, and I say OK, and then I will be going to use the polyline tool. I will draw 3 triangles, making sure that the horizontal and vertical lines are recognized, and that I will have a closed sketch here by clicking in a way that I will end up at the first point of this triangle here. Okay, so I will do the next triangle. As you can see on the lower right corner of the cursor, the solver does recognize a horizontal constraint. So I will click here and I will finish. As you can see, I make sure that there is a small point appearing in the lower right corner at the cursor, so that auto-constraining coincidence is enabled. I will use the polyline tool once more. And I will do last triangle. Okay, so now we have all triangles finished. Now we have 16 degrees of freedom in our sketch, and a good way of constraining is to first set the obvious geometrical constraints, because they will need less CPU performance than the dimensional constraints. So I can highlight all of the horizontal and vertical lines and apply an equality constraint to them. Now the next idea is to apply symmetry to these 2 points, and then I will also apply symmetry to these points, and then I will apply symmetry here, and we are left with 3 degrees of freedom left. Applying symmetry here would over-constrain the sketch, because I applied symmetry here, and I applied symmetry here. It is in mathematics now obligatory that this must also be symmetrical. You can try and you will see that you get an error message from a solver. So now I'm going to set a distance between the origin and this line. The distance should be 56 millimeters. And I'm going to apply, now the point is highlighted. Okay, now I have highlighted these 2 points, and I will apply a vertical distance of 100 millimeters. And then I will apply here a horizontal distance between these 2 points of 130 millimeters. Okay, the sketch is now fully constrained. Let's close it. As you can see here, the sketch has the wrong orientation, or to say the wrong placement. So I can also change the placement of sketches in FreeCAD. I will do that now. I highlighted here the sketch, that's okay. And now to change the placement, I will click on the 3 points. And I, as you can see here, will have to do a rotation around the Z-axis. Okay, I change to the Z-axis. Oops. I apply incremental changes, that should be ticked first. Then change to the ZX. Now we are correct. And if I say 45 degrees is the change, as you can see here, we move the sketch in the correct position. I click on apply and say OK. OK, the next operation will be to highlight the sketch and to use the pad operation. We will apply a length of 60 millimeters, symmetric to plane. This looks really good. We apply OK. And then we will change to the part workbench. We will highlight cad 003. We will press Ctrl and keep it pressed. We will also highlight pad and perform our cut operation. This looks really good, and it looks like we want it to be. Okay. So now for last step of our operation, we change back to the part design workbench. We create a sketch in the XZ plane. We apply OK. We'll draw once more our triangles. And this is the second one. OK. Horizontal, vertical. Here we go. Oh, I see. I did something wrong. So I do a right click in empty space to close the polyline command. And I do multi-selection of these two lines and press delete on the keyboard to delete them. You can also, if you are wrong with constraints, do a right click on a constraint and rename or delete it. And you can also highlight it with a left click and press delete on the keyboard to delete it. And now I didn't catch up with the right point here, so I will highlight this point. I will press Ctrl and keep it pressed and highlight this point and apply a coincidence constraint so that the triangle now is closed again. And I will reselect the polyline tool, horizontal, vertical. Let's move back to this point. Here we are, all 4 triangles now. Ready. So now we apply our equality constraint. Okay. We apply our symmetry constraint here. We have also symmetry applied here and symmetry applied here. Oh, my fault. Symmetry we did want. Okay. Now we have 3 degrees of freedom left. So we set the distance here to be 56 millimeters. We set the vertical distance here to be 100 millimeter, more than the 90 millimeter length of the cube. You can drag around the constraints in 3D space by highlighting them, clicking once more and keep the left mouse button clicked, and then Here we go. You can drag around the constraints in 3D to a position of your liking. And we have, okay, 1 degree of freedom left, so we will highlight these 2 points and apply a horizontal length of 130 millimeter. As you can see, I choose 130 millimeter because we need the cross-sectional length of this cube. One side of the cube is 90 millimeters, and cross-sectional length would be square root of 2 multiplied with 90 millimeter, which adds up to 120 something millimeters, so I choose 130 millimeter, and that's okay. So we close the sketch. The sketch is still highlighted, so now we can change its placement. We tick the box to apply incremental change. We change the axis to the z-axis, and the angle should be minus 45 degrees. As you can see here, the sketch is moving in the right position. We click on apply and OK. Now we will do once more a pad operation with 60 millimeter symmetrical to plane. That is OK. We change back to the part workbench. We highlight the 2 bodies, or the 2 shapes to be correct, and we make our cut operation. And that's it, the wiffle ball is complete. With this operation, we have reached the end of today's lesson. I hope you enjoyed watching. Please feel free to leave any comments, and maybe see you next time in another video. Bye!